Hey everybody, this is Larry, this is me going Q4 of the weekly contest 479, maximum subgraph score in a tree. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. This one took me a while. I was trying to think of other ways of doing it, some with like, I had ideas on with breadth first search or some kind of like connected components thing, but ultimately it is just a tree rerouting problem. What does that mean? Honestly, the naming is a little bit weird if you ask me, but I will try to draw it out after I put it up. Alright, so the idea here is just so you know, you have a lot of nodes, you know, you have trees and nodes and stuff like that, and it's not just a binary tree anyway. The idea here is that, okay, well, you know, given a node, we solve it for this node, right? And then given this node, let me write a couple more, hang on. We solve it for all the children, right? And then now, after we do two pass, this is the general idea. You solve it for each node, and then now for each node, you solve it for all its children. So then now, for example, this node would have the answer for all the children below, all the subgraphs. And then now the second pass is that now, well, if you kind of think about rerouting, now we want to pretend this is the root, then what happens? Well, that means that if this is the root, and you kind of like, I don't know, the way that I do it is I tilt my head a little bit, is that, well, we solved it for this part. Let me change the colors again, hang on. We solved it for this part, but we didn't solve it for this part, right? The other half of the tree. And the other half of the tree, then if you look at this from the other thing, is that we start with this node, and then we just kind of, like we already know, for this node, we already know the answer for this node, right? So then now, we take the answer for this root node, we subtract out this subtree's answer, so then now, and if you do that, then now you have this answer, right? And then now if you have this answer, then you can apply it to this answer to get the final answer. That may be a little bit confusing. Let me try again. The idea really is just try to figure out with these rerouting, is just try to figure out how to construct all the things that I just said, right? Because now you think about all these components, right? And you know, right? Because then now you have, you know, you figure out this one, for this one you figure out all the subtrees, right? So then now you're just trying to figure out, oh, what is going on with my thing? Huh. Sorry, friends. What the? Okay. Right, so now you have these things. So then now you're just trying to figure out the other half. And the other half, you know the answer for this thing. So then now the answer for this thing, subtract out the answer for this thing. Because this thing, the pink one, the answer is this, all these things, right? Including the pink node. So then now you just subtract out these things, and then you get here, this thing. So now once you have the answer for just that one, which is the parent without the subtree that connects it to, then now you can use this answer in some way to reapply to this. What I said is true for every tree rerouting problem. It's not just specific for this problem. It's just that for this problem, what's specific is how do you get, quote unquote, the score and the components and stuff like that and how they all fit together. And that part we'll go over in code. Because I don't think it's super tricky. Maybe I'm wrong on this because I took a long time, so who am I here to say? But yeah, basically this is the first function. This one gets the scores for a given node and all the subgraph, right? Subgraph, subtree, subnodes, right? And this one looks pretty straightforward, hopefully. You're given a node, you're given a parent. This is just standard tree traversal so that you don't go up the tree by accident. Otherwise, you know, you just go back and forth. We set the current score to be equal to, you know, if it's good, we +1. If it's bad, we -1. This is defined in the problem, right? And then now for each edge, we don't go up to the parent. We get the best score of that subgraph. And if that subgraph score is greater than 0, we add on to it. What that means is that if the subgraph has negative, it means that it doesn't necessarily, I mean, it has to mean that there are more bad nodes to good nodes, but also means that that's the best path that they can do. If the best path that they can do is negative, then you just don't take that path, right? That means that if you think about it as a tree with a node and you have like multiple branches, well, if one of the branches just gives you bad nodes, then just get rid of it. You don't add it. So that's what the greater than 0 means. And then we just sum them all up. And this gives us the score for a given node for all the subgraph. So far, so good. This part, the second part, a little bit trickier, but apparently a lot of people didn't struggle with this one, so it's fine. It's just that for me, and this is the way that I do it. There are other ways to do it. You can actually, you can actually do this in different ways. But the node and the parent is the same traversal. P-score is basically what I call the parent score. Is the score that you pass in that has the score of your parents, right? And in this one, the current score, this is the score. So score 2 is equal to the score, right? Plus the P-score if it's greater than 0, right? Because this score gets passed in, the same thing as the other analogy, right? If you pass in a negative score, we just don't take it from that side of the tree. So we can just pretend it's 0, and that's what this does. And then this is the traversal to kind of go down, right? S is the current score. So the new P-score, I think this part is a little bit tricky to visualize, but you should draw it out. During the contest, I did draw it out, for example, right? Is that, okay, if you have this node, you're trying to go down a node, right? Well, one is that you want to subtract that subtree to get the parent score, right? So that's what this means, right? And we only subtract from it if it is greater than 0, because otherwise current score would have already not taken into account. So this is the new score that does not count the subtree that you're let me just draw it out. Hang on. But it basically just means that you're not counting the subtree that you're going into. So let's say you have something like this, right? Let me just redraw it. So you have like a lot of circles, right? So then, so let me finish drawing it. Actually, this is I'm lazy, so this is binary tree. So let's say you already have this one, and incoming is the P-score, which contains all this stuff, right? And then now you're trying to do a recursion, and recursion you go down from here to here. Well, first of all, so now the recursion is fine, but what is the new P-score, right? Well, the old P-score is this thing, right? So then now the new P, and you know what this score is. So then now the two things you want to do. One is that you just want to narrow it down to this score. And the cyan score is just the outer red score, this one. This score minus this score, right? Oh, no, sorry. I said it wrong. Let me use another color. So the cyan score is equal to this score minus this score, which is what I have in code, right? Oh, I didn't show it. Oh, man. All right, sorry, friends. Oh, let me try again. I am a Dumbo. But yeah, so let's say, you have, you have this thing, and here you already have the P-score, which is going to be this thing, right? Which we already factored in, and let's just say we already given and it's correct, right? So then now you're trying to go down a level and recurse. Well, what does that mean? What is the new P-score? Well, we want the new P-score to be this score, right? And we already have the green part. So then so then now we just need to find this part, right? And this part, the pink part, is just equal to this part, the red part, right? Because that's just the actual score, the full score of this node, minus the full score of this node, right? Or node, but you get the idea. So once you subtract those, then you get the pink score. The pink score plus the green score is equal to the blue score, and that's basically it. It's all, when you draw it out and visualize it that way, then it makes more sense, and that's basically all I have with respect to, we update the P score. This is the old P score plus the thing that minus this part. And the reason why we have this if statement is that if it's negative, then we would not have added it in because we have this thing, right? So we would not have added this if it's negative, so then we don't subtract it. So this is basically the opposite of this to kind of get back into it, the current score. And that's it. We look at each node once, we look at each edge once, which, for a tree makes sense. It's going to be linear time, linear space, and that's it. That's all I have for this one. Let me know what you think. Thanks for watching. And yeah, apparently there is a template for this on Codeforce or something, and a lot of people did it fast, so I don't know. Let me know what you think. But this is how I did it, and if you watch the video, I generally do these from fresh, if you will, every time. So yeah, that's it. That's all I have for this one. Let me know what you think. Thanks for watching, and you can watch me solve it live in the contest now. Hopefully no more wrong answers. Okay. I mean, I was taking my time because I've been wrong a lot, But people were so fast on this one. I mean, I took a long time, but well, power of AI, I guess. All right, Q4 maximum subgraph score in a tree. You have an undirected tree and nodes. Edges n-1. I mean, okay, this is just showing up a tree. I don't know why I'm taking so long to read. Good sub I, if the I of his node is good, okay. Subgraph is the number of good nodes minus number of bad nodes in that subgraph, okay. Number of good nodes minus, okay. For each node I, return the maximum pop score among all connected subgraph that contains I. Okay. How do I think about this? We didn't have to go to the leaf, right? So, people got this so quickly. Okay, let's look at this, right? So you have 3 nodes. Okay, fine. This is just trivially true. Okay, here, what the green nodes are good nodes or something? Green nodes are good. Okay, so then now if you have just 1, 3, and 4, you I feel like it's going to be some sort of like binary search, or not binary search, breadth first search type thing. Okay, so it doesn't matter which green node you'd start, I think. I think this is one of those things where they're really only... maybe that's not true. But you always want to start at a green node, you buy first search. Right, you always start at a green node because it doesn't matter. Right. That might not be maximal though, right? N is 10 to the 5th, so at least it's big. Start any green node, and then what happens? Any other constraints I don't know about? No, it seems pretty general. Okay. Well, it's a tree, so the shortest path thing applies, right? So then now, if we do like a thing, then it is just okay. So you color all the things. It's like a weird shortest path farm. I don't think it's anything beyond that, but it is very annoying. I'm trying to think for all the cases before implementing it, I suppose. -1 is a minimal answer. Okay, so you could start with green node, breadth first search. It's not just breadth first search though that feels like it's a part of the idea. No, I think it's breadth. It's all source shortest path from that. No, Okay, so let's say we have all the components, then is it Dijkstra? I mean, kind of, but it's like a weird BFS where, okay, you start with the biggest component and then just BFS one step at a time from frontier, right? I guess that handles. So is it Dijkstra? Really Dijkstra? No, that's not it. Well, at least not by itself, because then you can have two things that merge, and then now the frontier is a little bit better, right? Huh, what am I missing? I feel like I'm missing an invariant. How much time do I have left? An hour. We should have plenty of time. I mean, that is a core idea, but you have to be able to merge multiple things. I think that's the thing that I'm missing the logic behind. The connected component is pretty trivial to begin with on the good nodes, and then the not so good nodes, what do you do? Is there a DP? It's not breadth first search. I mean, it's not shortest path rather. Maybe there is a BFS type solution, but it's not the shortest path, because you can connect multiple bad nodes to one good giant node, right? Is there a rerouting solution? I don't know, but it still may be n squared due to the star graph if we're not careful on the rerouting. Honestly, I'm not as strong as rerouting. I haven't done rerouting in a while. can I do rerouting? Maybe it is rerouting. Because then now you just get the answer for this node is independent, right? I think it's rerouting actually. Okay, what does this look like? So what is the recursion, right? So what does that return? Returns the best thing that's connected. Right, so maybe this is score, right? And then current score, maybe here. And then here, if score is greater than 0, then current. Something like this. And current score will be 1. Something like this, I guess. Okay, so let's say the 5, does that work? Okay, let's say the 5 nodes is -1, so then it returns 4. Okay, so I think this works, but it doesn't do the rerouting yet, right? That's just for the subtree. How do I it's been a while, I have to think about how to do rerouting. Right, okay. Let me just say score. Okay. And then now it wants the parent, right? The root is fine. So then now how do you do the rerouting again? It's so you get the parent. The parent. Okay, so let's say I'm at parent. So then now okay. Right. So then the okay, let's think. Okay, okay, so let's say I'm at the parent. I need to draw this out, but I didn't take my notebook. Okay, so I'm here. I have the score of everything, right? And then now here, I want to say score of so the contribution is going to be if this is greater than 0. Okay, so score is equal to score sub node. Right, so then now this if this is greater than 0, then current score -1 or minus score sub user, because we added it, right? So then now we want to pass this to right. Yeah, I'm missing something, but it's fine, maybe. Okay, so this is the current score. We subtract it out, and then we subtract it out, and then it is going to be all the other nodes, right? Okay, that part is fine, but then now we have to do one more thing, which is that, okay, now pass it in, right? Now we have to keep passing. So with that plus, okay, that's fine, right? So this is, and then we have to add the other p score too, right? Wait, so you go do. I really need pen and paper for this. Okay, fine. Okay, there it is. Actually, wasn't that hard to find. I don't know, I didn't. Okay. So we have this. Okay, so then now we pass in this, right? Now what? Then now to pass here, it is going to be this component plus the p score, if the p score is greater than. Okay. There is a plus -1 component that I'm kind of trying to figure out where to do it at, but I think this is fine, right? So okay, so then now okay, that plus p score, I think that's actually good enough. And then now score 2 is equal to score of node plus p score if p score is greater than 0. Okay, maybe something like this. Then we take the parent, and same thing here, really. We only this is without the contribution, but then it may be that this is negative. If this is negative, we don't want to take it, right? So here maybe we write something like I guess I can run this here too. Something like this, maybe. I don't think this is right, but I mean, it's probably it should be in the right direction, but yeah, okay, I forgot. That's a thing. I'm so rusty. Why am I pressing my buttons? Where do I use it? Did I reuse score somewhere? Oh, I do. Okay. What is the answer? Well, definitely has more than none. Why do I have nuns? Because this should never be none, right? Should at most be. This should be at most 0, right? Why is this none? Huh? Two. Yeah, so why is this not populated? Node, parent, score of node. Oh, wait, no, this is score 2, that's why. Okay, I'm just being dumb. Okay, so score seems like it probably should work. Score 2 though, not so much. Oh, because this only recurs when it is greater than 0, which is not quite true. I think. Yeah. 1, 1, 2. I mean, this is 1, but that's fine. Why do I think this is 2? Score, p score, node, score, node, p score. So okay, so at parent 2, at node 2, index from 0, the p score is 1, which is not true. Because we hit the -1. So that's the part that I didn't factor in, I suppose. So you have to combine it from all the other edges. So it's the current score should combine it, but I think the 0 kind of messes us up. So I think maybe we have to do something like, how do I handle this? Maybe that part is just not. I mean, it's more right, but this one is wrong. So something here feels sketched though, for sure. Because I should, this current score takes account that, but we should not. So this is only if it is positive, because otherwise we don't contribute to it, right? So the score is score if score v is greater than 0. Because then we don't take it anyway, right? So, okay. All right, now it's just really wrong, but why though? Oh no, because it's just us. Okay, I mean, it passes the things. Honestly, I don't think this is right, but I'm gonna YOLO submit so I could get a quick wrong answer, because 48 minutes is a good time, but I think it's a good try to get a quick wrong answer so we could debug. And I was wrong about being wrong. Apparently I'm so wrong about everything today. On the easy ones I got wrong. I mean, I'm happy with this actually. Like, I obviously did better than I expected. I really did expect this to be wrong. I was not confident about this at all. I in the sense that, like, in general, I think like I thought the idea, the template, everything is correct, by the way. I don't mean to suggest that like I was really off base, but I just thought maybe there's a lot of easy off by one situations, because I had a feeling that I had to handle the good bad notes here explicitly. It's kind of baked in the current score, but it doesn't feel, because current score gets, you know, here, but it doesn't feel very confident. I don't feel very confident about it. But yeah, I mean, you know, pretty happy that I got it, even though 4 wrong answers a little bit sad. But thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy to good mental health. I'll see you all later and take care. Bye bye.